Hello, I'm JW. This time I've got some things which have been sent in, and what they are, these circuit breakers. These are probably from the 1980s. We'll have a look at the note that comes with these in a moment. And there's a set of 5 of these on this back plate, so fairly grubby, but then old stuff does tend to be. And this is just one of many things that have been sent in that haven't been got around to recently, but we'll be getting through these eventually. So if you have sent things in yourself, they are somewhere in a big stack waiting to be dealt with. Now here's the note that comes with this one, and it says a 5-pack of breakers taken out from an apartment which was built in 1983 in Prague in the Czech Republic, which was formerly Czechoslovakia, or at least it would have been at the time. This entire set was used for 1-bedroom apartment, 2 rooms in total, and was connected to a 25 amp main breaker, and we've got 10 amps for light, 16 for the outlets. And in terms of manufacturer, we'll have a look at the thing in a minute. It does say on the front Siemens system, but that doesn't necessarily mean that they actually made them. They may have been sort of rebadged for someone else or whatever. And there's also a switch, which we'll have a look at a bit later as well. So thanks for sending those in. So let's just have a look, see what we've got. So here they are on this what looks like galvanised steel backplate. Fairly dusty, but then things of that age would generally be. So 5 of these, and as we can see there, not a whole lot of information on the front. The rating is there in very small print there, so this is the 10 amp, and we've got some 16s as well. Quite a substantial depth there compared to more modern items, which generally are quite a bit shorter there. And these are just circuit breakers, they're not RCDs or anything like that. Bus bar at the top here connecting them all together, and presumably the outgoing circuits then would have connected here at the bottom. And again, this is fairly typical for ones of this age, even the ones you get in the UK, where all of the actual terminals are pretty much exposed there, so live parts once you've taken the front cover off. And again, live bus bar obviously exposed there as well. Fairly standard sort of rail on the back there, then there's clips on there, plastic bit at the bottom, and then the peg piece at the top which just clips over. And also this would have been mounted in some kind of enclosure with a front panel. Now these do have a nice snap action on these, and it's actually a lot better than quite a lot of modern circuit breakers. So that's on, and then that's off. So it's a very solid and sturdy kind of action there, so fairly decent. Let's have a look at the label. So it's a closer look there, and you can see on the actual toggle it does have the 0 and then the 1 marking for off and on. Siemens system at the top here, and then we've got this large W, the logo of the particular brand of these. Rating is printed on, but in actually very small writing, so 10 amp there, 16s on the others. And I've got the 3000 there, which is presumably the braking capacity, 3000 amps or 3 kA, 220 volts AC, and various other incredibly small numbers just marked on the front there. And so just screws there to secure the outgoing wiring, and then the incoming at the top. Now this bus bar at the top just goes in there to the fixing there to hold them together. This has also been cut from a considerably longer piece. You see the angled piece at the end, so I presume this comes as a fairly long length, just cut it down to size. Now this bus bar is not copper, it's far too light for that, so it probably is just aluminium. And you can see where it's deformed there, where the screws have bitten into it and been crushing that down for many decades. So it feels like aluminium or some kind of alloy, not copper. Of course, copper would have been fairly more expensive. And so it just goes into the holes on the top there, screws just biting down onto that. And in terms of how these fit on, it's just a little clip just on the back there, so that just pulls up, and then the actual thing just pulls off and detaches like that. See the original colour there, and obviously the rather grubby front part where it's discoloured, ended up being exposed to the air and obviously the general environment. Now this is the back of one of them, and I've got H5L16, 16 presumably the rating, and we've also got 2681, which might well be the date code, so presumably week 26 of 1981, so that would kind of fit in if this was put in an apartment built in 83. So it may well have been on a factory or warehouse somewhere for a while before it was obviously installed. Now they're held together with these rivets here, just 4 pins that go through, and then the other sides are just domed over. So I'll drill out one of these, we can then have a look inside. Now I'll drill this one out, just remove the heads there from those pins. This is again one of the 16s, but they're all going to be fairly similar inside, so I should be able to push these pins through and hopefully see what we've got inside. Yeah, again, these pins feel like aluminium. They drilled out incredibly easily, so probably a very soft alloy there. Not that matters, of course, because they're only there to hold the case together. Not the sort of thing you'd normally be taking apart or being concerned about the strength of them. So 4 pins there, just holding the sides together, and then looks like we've got this top plate here, and the rest of it will stay hopefully in the bottom, and hopefully without too much stuff springing out. So that's what we have inside. Now I can see this has definitely had some use and tripped with a non-trivial amount of current, because we can see here a fair amount of soot and burning on the other side of the case there. It's just opposite the arc chamber here. This plate is slightly moved, but it would have obviously slotted into the peg pieces over there. So this is quite typical of most circuit breakers. I've obviously seen others of different makes before. So in this case, the power is going to come in on the top here, and this is the contact here. See that round piece on there, and then the other half of the contact is here. Just trip this to the off position, otherwise it might have a danger of springing out. And you can see there's obviously a fair bit of carbonisation on the back where it's obviously tripped in the past. These are the plates which just form the arc chamber, just again there to divide the arc up and dissipate the heat there, all actually separate. And at the bottom here we've got the 2 trip mechanisms, so this will be the magnetic coil here. You see the current will go via this lead here through that, and then across the bottom to the output terminal. And then this is the bimetallic strip here. So as with most of these, the magnetic part is designed for things like a short circuit, where you're going to get a very large current flowing. And then the bimetallic strip is for moderate overload, so this will gradually heat up. As it does so, it will gradually bend, and again just press onto the trip mechanism there and cause it to be disconnected. Nice wide gap on the contacts there, so I'll just take those plates out of there. So that's in the open position there, so you see there's a decently wide gap, and again those plates would absorb some of the energy from any arcing that occurred, and in the closed position that would just swing up to the top there, and that's it in the closed position there. So just 2 round contact points here. Current coming through here via the braid here, through the magnetic coil, and then out via the bimetallic strip and onto the contact here at the bottom with the outgoing wiring to the circuit. So the trip mechanism is basically this here. So that with a thermal trip there, so it just literally bends up, and there's a little spring there just to push it back to its previous position. Only disadvantage with these, and this happens on others, if they do get very hot, you won't necessarily be able to reset it straight away, because it depends on the position of this strip. So it's necessary to wait for it to cool somewhat, but that's pretty much the case with all of these. So just reset that again. There's obviously a pivot which goes in here, which is on the other side of the case there to hold that in place. And the magnetic trip again is this same piece here. It's either pressing on this one or this one. So again, that trips there just the same. And it appears this is actually one which would attract the end of the piece of metal there. So magnetic coil, and there's that very small gap there. So when this is magnetised, it will basically pull that against the end of it. Move that separator out of there. So that little piece in there is what's going to be moved against the magnet here. and that will trip the device. And we can see there the actual snap action, so even if you move the lever slowly, it does have that good click between the closed and open positions, obviously to minimise the arcing between the 2 points. At the bottom here under the plastic cover there's this little screw here which would be the adjustment used at the factory, so that would be turned in or out and that would set the thermal trip current. So as that was screwed in, it would then press on the bar here and move that closer towards the trip point, therefore decreasing the current needed, and if it was done the other way it would obviously move it down. So just to set that thermal trip point there. The magnetic part won't have any adjustment, that's just going to be based on the number of turns inside and also the magnetic force it creates. And that's also why the specification to most breakers, the actual thermal trip part is fairly accurate in terms of the current there, and this one is generally a more of a coarse thing, so to say 3 to 5 times the rated current for a modern Type B. This is the magnetic coil, and you see the centre core there, and it's just the strips of copper actually wound around it, so obviously insulated from each other. See, there's the edge of the plastic insulation there. So unlike others I've seen, which is just basically a wire coiled around, this is actually a flat strip of insulated copper, just put around the appropriate number of turns, and then just got this plastic spacer piece at the bottom there to obviously support that. This is the trip bar basically for the magnet and the thermal one, and as we can see there from this screwdriver it is attracted to a magnet, so in this case it's actually pulling it towards the magnet here rather than repelling it, but serves the same purpose. Obviously it's either pressed by the bar there or pulled onto the magnetic piece in the centre there. So that's the Czechoslovakian breakers, and pretty decent design really. I mean, considering what we had in the UK at the time, a lot of people were still on the rewirable fuses and those dreadful Wilex breakers with the round button on the front, the style where you put it in your cupboard, and because the red button underneath was protruding, your coats things hung up and it just brushed against them and tripped out the entire circuit. But certainly no danger of that with these. These are a very sturdy trip mechanism on there. Now this is the other switch which was mentioned on the note there. This is a waterproof or at least water resistant switch, got a little water droplet symbol there. Brown material, a bit of paint on, as everything of course has. It doesn't matter which country it comes from, slapping emulsion paint over everything is basically the requirement. A very slight movement on the actual button there, it does still work, but certainly doesn't move far, so let's just have a quick look inside, see what we have. Okay, so there we go, so fairly ordinary sort of switch mechanism inside, and then the whole front here is this rubberized material, and then that just presses through on that moving piece there. So yeah, definitely going to be pretty much water resistant or waterproof there. That's contained and encloses the entire thing. Inside here it is just a one-way switch, so 2 terminals there, and just the 2 wires, the remains of which are still inside. And we've got this rubber piece on the top. So yeah, there's the switch, say 2 terminals, obviously connected through or not, depending on the position of the front piece. This looks to be a sort of bakelite type material, just the support posts inside, threaded inserts there rather than just graunching into plastic, and see the metal inserts down inside the back there. So certainly water resistant from the front, but you would have to be a bit careful on the back there, obviously where the cable comes in, but then pretty much standard fare for most things you can even get today. So thanks for sending those in, and say quite decent construction inside, certainly nothing too surprising there, in fact very similar to a lot of modern circuit breakers. But that is it for this video. Until next time, thanks for watching.